A leftover chunk of an ancient tectonic plate is on the move beneath North America, right under the southern part of the Cascadia subduction zone. This isn't some harmless debris. It's a real slab of Earth that never fully disappeared. And because it's still sliding around down there, it could be adding a whole new layer of stress to a region that already has a reputation for massive earthquakes. The story started with weird signals showing up in seismic data. It's basically Earth's X-ray. Scientists send waves through the ground and watch how they bounce back. These waves started acting wrong beneath the Pacific Ocean off the western US coast. Instead of smooth, predictable patterns, researchers saw a giant, coherent block deep below the seabed, moving differently from everything around it. It didn't look like a landslide, didn't look like loose debris, and didn't behave like normal ocean crust. That's when someone dared to ask the question out loud. What if this is something much older and much bigger than we thought? Some researchers seriously wondered if this could be a remnant of a lost continent, maybe a forgotten shard of Pangaea, the supercontinent that once stitched almost all land together. Technically, it's not fully impossible. Continents break, sink, stretch, and vanish over millions of years. This fragment was enormous, solid, and oddly shaped, which made it hard to classify. It didn't fit into the usual categories scientists use to explain underwater structures. Then came the slow, careful reality check. Scientists brought in more data, better models, and deeper analysis. They measured the age of the rock, studied how seismic waves bent through it, and compared its motion to known plate movements. That's when the picture shifted. This wasn't a lost continent at all. It was something just as dramatic, but far more dangerous. A massive leftover fragment of an ancient tectonic plate. This fragment turned out to be a survivor from the Farallon Plate. This ancient plate once dominated the Pacific, but got mostly swallowed as it slid beneath North America millions of years ago. Most of it vanished into Earth's mantle, but not all of it went quietly. This chunk survived like a splinter that never fully sank. Researchers named it the Pioneer Fragment, and the name fits because it's charting territory we didn't even know existed. And this fragment isn't just drifting harmlessly, it's moving horizontally beneath North America, which is weird and dangerous in geological terms. Normally, plates collide or slide past each other in predictable ways. This fragment behaves like a wrench jammed into a machine that already runs under insane pressure. The West Coast already balances on fault lines that store stress like stretched rubber bands. Add a giant moving rock slab underneath, and suddenly the system becomes harder to predict, harder to model, and much harder to feel safe about. The region where this fragment lurks already scares geologists. You've got the San Andreas Fault, famous for snapping without warning. You've got the Cascadia subduction zone, capable of producing earthquakes so powerful they rewrite coastlines. Now, scientists realize there's a hidden player deep beneath the ocean floor, something satellites can't see, and scientists can't directly observe. This fragment doesn't follow clean, predictable rules. Think of it like stacking dominoes on a table that's already shaking. It moves slowly, but in geology, slow movements still means unstoppable force. And when that built-up energy is finally released, it won't care about evacuation plans or building codes. There's also a timing problem that nobody likes to talk about. Geological processes don't run on human clocks. Stress can build for centuries and snap in seconds. The Pioneer Fragment might trigger something tomorrow, or it might sit quietly until generations forget about it. That uncertainty makes planning brutally hard. Cities like Los Angeles, San Francisco, and Seattle already prepare for known earthquake threats. Now, scientists must consider a system that can amplify disasters in ways nobody has practiced for. So, scientists now race to update models, improve seismic imaging, and understand how this fragment interacts with nearby faults. They know they can't stop earthquakes. All they can do is reduce surprises. And it's also clear that sometimes the most dangerous threats aren't coming from space, but sliding quietly beneath the sea. Another recent ancient landmass discovery wasn't nearly as dramatic, but super important for science. It started as a sand dredging operation off the coast of Indonesia, but then archaeologists found more than 6,000 fossil fragments from a lost submerged ice age landmass. Among them were 140,000-year-old Homo erectus remains. That single find forced scientists to rethink how early humans lived, moved, and interacted across Southeast Asia. For a long time, researchers assumed the Homo erectus population on Java lived cut off from everyone else. But those dredged-up fossils proved that Java wasn't an island. It sat right in the middle of a massive Ice Age landmass called Sunderland. Indonesia, Malaysia, Borneo, Thailand, and Vietnam are all connected into one enormous landscape. But we now call islands like Java, Sumatra, Borneo, and Bali were linked together through huge river systems that probably rivaled the Amazon. Dense forests stretched across the land, giant animals roamed freely, and wide coastal plains existed where ocean waves sit today. And Homo erectus didn't just survive there, they thrived. And no, this wasn't a snowy wasteland, unlike how we mostly imagine the Ice Age. Sea levels dropped more than 400 feet because so much water was locked up in glaciers. When that happened, massive chunks of the ocean floor rose above the surface like natural stepping stones. Early humans didn't need boats. They could literally walk from mainland Southeast Asia to places we now think of as isolated islands. They moved while tracking animals, exploring open land, and following food sources. It worked like a giant prehistoric highway system. When the Ice Age ended, glaciers melted like forgotten ice cream cones on a hot sidewalk. Sea levels rose, slowly at first, then fast. Rivers overflowed, coastlines vanished. Entire human landscapes slipped beneath the waves. Over thousands of years, Sunderland drowned, and the people who lived there had to adapt or move to higher ground. Now, archaeologists piece together this lost world bone by bone, artifact by artifact. Every new discovery pulled from the seabed brings us closer to rewriting the story of early human migration. Studying submerged landmasses and lost continents is a work that takes years. In 2017, scientists made an announcement that changed this universal truth that there are 7 continents in the world. The discovery of Zealandia. Zealandia's story ties straight back to Gondwana, the ancient supercontinent that started breaking apart hundreds of millions of years ago. Around 80 million years ago, Zealandia split off too. But while Australia stayed high and Antarctica mostly held its ground, Zealandia slowly sank. Only a small chunk stayed above sea level, even though many geologists argue it still qualifies as a full continent. That little bit you can actually see today is mostly New Zealand, along with a few nearby islands that also belong to Zealandia. By the end of 2025, scientists had finished mapping the northern 2/3 of it, covering nearly 2 million square miles of submerged land. Researchers dredged rock samples all the way from the Fairway Ridge to the Coral Sea. They pulled up all kinds of material: pebbly and cobbly sandstone, fine-grained sandstone, mudstone, bioclastic limestone, and even basaltic lava. And these rocks came from wildly different time periods. When researchers lined all this up, they saw something big. The internal stretching from both Zealandia and West Antarctica caused the crust to thin and crack in a way similar to subduction. That cracking let ocean water rush in and helped form the Tasman Sea. A few million years later, Antarctica continued pulling away, stretching Zealandia's crust even more until it thinned so much that sinking became inevitable. This directly challenges the older idea that Zealandia broke apart mainly through sideways strike-slip motion. The team also thinks the direction of that stretching shifted by as much as 65 degrees, which likely helped the continental crust thin out way more than expected. It's one of America's strangest contradictions. The Northeast, the cradle of cities, commerce, and crowds, hides a vast, empty wilderness at its northern edge. Millions live packed together to the south, yet up here, there's space for everyone, and almost no one takes it. How did this happen? How did the heart of America's most crowded region end up with one of its loneliest frontiers? The northeastern United States is home to more than 50 million people, It's one of the busiest and most densely packed regions in all of America. But almost 90% of those people live in the southern half of it. If you go north, past big cities and highways, everything will change. The noise will fade and the lights will thin out. You'll find yourself in a different world. A quiet land of forests, lakes, and mountains, stretching across northern New York, Vermont, New Hampshire, and Maine. This is America's empty Northeast. And the mystery is simple. Why is this part of one of the most crowded regions in the country so empty? First of all, let's take a look at New England itself. Massachusetts and Rhode Island are bursting at the seams, while Maine, Vermont, and New Hampshire feel wide open. Connecticut sits in the middle, literally and figuratively. Massachusetts is basically the crowd magnet. Most people live around Boston and the cities nearby, Cambridge, Worcester, Springfield, where everything's close, busy, and built up. Rhode Island may be tiny, but it's got a big city density. Connecticut sits right between Boston and New York, and it shows. It has a busy coastline and quieter inland towns. It's not too crowded and not too empty. The middle ground. Once you cross into New Hampshire, things slow down. There's Manchester and Nashua, but most of the state is forests, lakes, and open land. Then there's Vermont, easily the least crowded region of the bunch. The Green Mountains slice through the middle, and most people live in small towns or villages. And Maine is huge and mostly empty. Most people stick to the southern coast. If you head north, you'll hit endless forests, lakes, and long, quiet roads. It's beautiful, but it feels like the edge of the map. Today, the northern half of the Northeast, northern New York, Vermont, New Hampshire, and Maine, holds only about 4.9 million people. That's roughly the same as the population of the Boston metro area alone. To put that in perspective, if you take southern New York and southern New England, about the same land area, you get 10 times as many people living there. So, why the gap? It all comes back to geography, history, and economics, and how they've always worked together to keep the North empty. Let's start with the land itself. The thing is, the farther north you go, the rougher the land gets. Southern New England and downstate New York are full of rolling hills, wide valleys, and coastal plains. But then come the mountains. They're old, crumbling, and wild. In northern New York, you'll see the Adirondacks. To their east, the Green Mountains run up the middle of Vermont, stretching into Quebec. Keep going and you hit the White Mountains of New Hampshire. They're home to Mount Washington, famous for some of the most severe weather on Earth. And beyond that, the western Maine Mountains roll on toward Canada. Those aren't gentle hills, they're real barriers, and they owe their shape to one of the most powerful forces in Earth's history: ice. During the last ice age, huge glaciers covered this land. When they finally retreated, they carved out deep valleys and left behind thin, rocky soil. Later, the basins filled with water, creating thousands of lakes and ponds. It's a beautiful but difficult land to live on. Farming never stood a chance here the way it did farther south, where the soil is way richer. So the mountains stayed wild, covered in dense forests that even today stretch for miles. Northern Maine and the Adirondacks together make up one of the largest continuous forests east of the Mississippi. For centuries, people have come here to cut timber, fish, or hunt, but never in great numbers. And then there's the weather. Up here, winters are long, dark, and cold. Snow piles up early and doesn't leave easily. Summers are short, and the growing season is barely long enough to farm. It's not exactly a place that says, "Come start a new life." But of course, some people did. And here's where history comes into play. Long before Europeans arrived, this land was home to indigenous nations. The Abenaki, living across Vermont, New Hampshire, and Maine, had complex trade routes, connecting their communities all the way from modern Quebec to Massachusetts. Farther west, the powerful Iroquois Confederacy extended its influence toward the Adirondacks, controlling vast hunting grounds and trade routes. Then came the Europeans. In the 1600s, French explorers and fur traders pushed south from Quebec. They set up outposts along rivers and lakes that linked the region to Canada. They saw opportunity: furs, fish, timber, but not farmland. The dense forests and harsh winters kept settlements small and scattered. The English, expanding north from the Massachusetts Bay Colony, took to the coast. They settled in southern Maine and New Hampshire, but going inland was another story. Between the cold, the forests, and the resistance from native nations, their progress was slow and dangerous. For more than a century, the interior of the northern Northeast stayed wild. Later, around the 1760s, the British took control of the region. Land speculators moved in, especially in Vermont, which both New York and New Hampshire claimed as their own. The overlapping claims led to chaos, and eventually, Vermont declared itself an independent republic in 1777. For 14 years, it existed on its own until it joined the United States in 1791 as the 14th state. New Hampshire pushed inland from the coast, building towns in the valleys between its granite mountains. Maine, meanwhile, spent centuries as parts of Massachusetts. Its economy ran on timber and shipbuilding. Trees turned into masts and planks for the growing British and later American navies. And in northern New York, the Adirondacks remained a wild frontier long after the rest of the state filled up. The land was too rugged and the winters too fierce. Logging, mining, and later tourism would bring people north, but never in huge numbers. By the mid-1800s, the southern parts of New England were booming. Cities were growing, factories were humming, and immigrants were arriving in large numbers. But the northern regions stayed quiet. So as we now know, the mountains are the first big barrier. They make everything harder: travel, building, farming, and surviving winter. The soil is thin, rocky, and poor. And what's underneath isn't much better. The region doesn't have rich mineral deposits or coal seams like the Appalachians farther south. Without valuable resources to mine or easy land to farm, there wasn't much reason for settlers to stay. That was one of the reasons why the economy never took off. The empty Northeast never became a center of industry. Southern New England had rivers that powered early factories, ports connected it to global trade, and the cities attracted millions of immigrants. Northern New England and northern New York had none of that. They had lumber, granite, and paper mills, all useful, but those industries didn't create huge cities. Even today, the economy up there relies on the same resources, along with tourism. People come to hike, ski, fish, and escape city life, but most don't stay year-round. Towns fill up in summer and fall, then empty out when the snow starts falling. A few small cities, Portland, Burlington, Manchester, thrive, but there's no Boston or New York up here. You won't find massive universities, corporate headquarters, or international airports to pull in young people and families. In fact, some states have gone so far as to pay people to move there. Maine and Vermont have both launched programs offering money to remote workers who relocate. That's a pretty desperate attempt to reverse decades of population decline. Today, this empty Northeast holds just about 1% of America's population. It's a land of deep woods, icy lakes, and quiet towns. The wilderness never really left this region, but that stillness is also what makes this place so special. The rest of the Northeast is filled with constant noise and motion. Meanwhile, the North is a reminder of what the region once was: wild, cold, and untamed. That's how the heart of America's most crowded region remains one of its last true frontiers. Have you heard of Thacker Pass in Nevada? Probably not, but you should. There's something so valuable here that the US government invested around $2.26 billion to get it. No, it's not oil. That's a bit old-fashioned, huh? It's lithium, the lifeblood of electric vehicles, smartphones, and renewable energy storage. White gold, so to speak. And successfully mining it out from Thacker Pass could maybe reshuffle the global balance of power. But first of all, why here? Why Thacker Pass? Well, it sits on the edge of something called the McDermott Caldera. Millions of years ago, a supervolcano blew. The ground collapsed into a giant crater. Over time, water collected inside it, forming a shallow lake. Volcanic ash and rock from the surrounding cliffs slowly eroded into the lakebed, carrying with them all kinds of minerals, including lithium. As the lake dried up, those minerals stayed behind, building up thick layers of lithium-rich clay. And for decades, it just sat there, untouched. But now, with interest in electric vehicles being at an all-time high, this area in Nevada has suddenly become one of the most important pieces on the energy chessboard. Lithium ions are tiny, fast, really good at carrying electric charge inside a battery. Think of it like a game of ping pong happening in there. When you charge your phone or laptop, lithium ions zip from one side of the battery to the other. When you use your device, they bounce back the other way, creating the power that keeps your screen glowing. But the best part is that this process can go on for a very long time. Sometimes 15 years or even longer. That's why lithium is perfect for things we charge over and over, like smartphones, laptops, electric cars, and even huge power grids. Other metals? They're often heavier, slower, or wear out faster. Lithium's lightweight, fast-moving nature and incredible efficiency make it the go-to choice for our modern, always-on world. Right now, the world can't get enough lithium. Thanks to the electric vehicle boom and the global push for clean energy, demand is skyrocketing. In just the last year, global lithium use jumped by nearly 25%, and the curve is only going up. By 2030, demand could quadruple, and it's only going up from there. Electric vehicles are driving most of this. Around 85% of all lithium produced ends up in batteries, mostly for EVs. And with gas cars on the way out, every automaker is scrambling to lock in their lithium supply. But it's not just cars. We also need lithium for smartphones, laptops, smartwatches, tablets, power tools, drones, and backup power storage for homes and cities. No more stretching long cables over your yard as you mow your lawn. And let's not forget battery farms being built next to solar and wind farms. All of them rely on lithium to store excess energy when the sun isn't shining or the wind isn't blowing. So the problem is, we're going to need a lot more lithium than we're currently producing. But that's not the only issue. Even if a country has lithium in the ground, that doesn't mean it controls the battery supply chain. Mining is just the first step. Then, lithium has to be processed into battery-grade material. And right now, China dominates that stage, refining around 70% of the world's supply. When the US, Chile, or Australia digs it up, it often ends up in Chinese facilities before reaching a battery factory. That's a strategic weak spot. If global trade gets disrupted because of geopolitics, shipping, or any other reason, the whole clean energy transition slows down. It's kind of like growing our own coffee beans but needing someone else to roast and brew them. You're still dependent, just at a different point in the process. That's why the US isn't just after more lithium. It wants the entire process, from mining to battery production, to happen right here at home. And Thacker Pass could be a big piece of that puzzle. With a $2.6 billion loan from the federal government, this isn't just a mining site. It's a test run for bringing important energy operations back to the US. If it goes well, America won't just be catching up. It might be in the game at full speed. So, what makes Thacker Pass different from other lithium sources? One word: clay. Most lithium comes from hard rock mines in Australia or salty brine fields in South America. Those methods are well established. But here, lithium is locked in claystone, a mix of ancient volcanic ash compressed over millions of years. That kind of deposit is rare and much harder to process. Getting lithium out of clay usually means cooking it at super high temperatures or soaking it in acid baths, which is not exactly cheap or eco-friendly. But if Lithium Americas pulled it off, it could unlock a whole new type of lithium mining, not just here, but across the western US. Early estimates say Thacker Pass could hold up enough lithium to power millions of EVs for decades, possibly the largest deposit in North America. That's why this project matters. It's not just about getting lithium. It's about proving that clay-based extraction can work. If it does, it opens up a new domestic supply. If it doesn't work, the US stays stuck in the same loop. Dig up some lithium, but still send it overseas to get refined and stay dependent. On the other hand, if Thacker Pass reaches full production, it won't just change where America gets lithium, it might reshape the entire region. The mine is expected to run for 40 years and could become one of Nevada's largest industrial projects. That means jobs, lots of them. Predictions say close to 2,000 people could be employed, not to mention the ripple effect: housing, schools, roads, hospitals, and support services. Economists call this the multiplier effect. One mine means more local jobs, waiters, teachers, grocery clerks. The whole town gets a boost. In a rural area like Humboldt County, that's a big deal. And it doesn't stop there. Having a domestic supply means prices stay more stable, sourcing is more secure, and we can increase EV and battery production all over the country. What used to be just a hole in the ground is turning into a national treasure for energy, jobs, and independence. Still think this is just me overhyping it? Let's talk money. The US Department of Energy just ruled out one of its biggest clean energy loans ever, $2.26 billion to get Thacker Pass going. General Motors is investing $650 million to get early access to the lithium they need for their EVs, making this their biggest raw materials investment ever. Tesla has already set up a lithium refinery in Texas so they can cut out the middleman. Even ExxonMobil is getting in on the action, planning to start lithium production by 2027 and aiming to be a major US supplier by 2030. When oil giants, car manufacturers, and the government are all putting their money on the same bet, that's definitely more than just a trend. That's a real change. So what happens if this lithium boom hits a wall? It's possible. Lithium is a limited resource, but the future doesn't rely on fresh mining. Battery recycling is getting better fast. Some analyses even project that future recycling could recover up to 90% of lithium, and new tech is making it cheaper and cleaner to do so. In theory, someday your dead phone battery might power someone's new car, and there's new battery tech on the horizon. Solid-state sodium-ion and thermal batteries are all in development. They're not ready to take over just yet, but they're coming. So no, we're not facing a lithium apocalypse, but we are in a race to mine smarter, recycle better, and stay ahead of future shortages. For now, lithium still runs the show. Somewhere out there in the Nevada desert, there's a dusty construction site that might just shape the future. Not just of batteries, but of global energy, manufacturing, and independence. Thacker Pass isn't just about digging for metal. It's about shaking up the supply chain, giving the economy a boost, and stepping into the clean tech game. If everything goes smoothly, this chunk of land could power millions of cars and help energize the country too. We just have to wait and see.